Hello, thanks for watching this video and studying your math with me. 2 points are worth keeping in mind. The first is that watching this material complements rather than substitutes for reading your text, and you can and should use the YouTube video controls to pause, rewind, or replay to test and or ensure your the first example has us identifying each set as finite or infinite and then determining whether 8 is an element of the set or not. So here we see that A and D are finite sets and 8 is in both of those, but B and C are infinite sets and 8 is in neither one of those. The second example has us listing the elements of the set. That's called the roster method. This is called the rule method. And we see that the natural numbers between 8 and 12 are 9, 10, and 11, and the only natural number greater than 6 and less than 8 is the number 7. The next example is examining subset relationships. We have a universal set and sets A, B, C, and D, and we have to figure out whether these are true or false. I'm probably not going to always ask you whether things are true or false, but also ask you to explain your answer. See here that B is not a subset of D because 9 is in B, but 9 is not in D. Moreover, B has 4 elements and D only has 2 elements. So that is false, and similarly C is false because this says that D is not a subset of A. That's false because every element in set D is also in set A. So D is a subset of A. In fact, D is what we call a proper subset of A. These are true, B and D, because here everything that's in D is also in B. That makes it a subset. And here A is contained in U, but there's something in U, 39 namely, that's not in A. So A is a proper subset and not equal to. Here's some fill-in-the-blank kind of considerations. So we see that the complement of a set A, denoted A prime, is a set of all elements in the universal set that do not belong to the set A. The intersection of A and B, you write it this way, is made up of all elements belonging simultaneously to both sets A and B. So there's an and in between there. And the union of sets A and B, written A, that's the union symbol, is made up of elements belong to A or B, or both A and B, and this is an inclusive or. The next example has us finding the complements of the sets, and so we have the complement of A here is the even natural numbers between 1 and 9, and so we have the odd numbers between 1 and 9 as the complement. B is a set of multiples of 3 between 1 and 9, and B prime then are these numbers. The complement of the universal set is the null set, denoted this way or this way, and the complement of the null set is the universal set. This talks about intersection. So we're to find the intersection of these and identify any sets that are disjoint. There is an element in common here, but the only one, and it is 30, so the intersection of those two sets is a set containing 30. Here, 6, 12, and 18 are in both sets, so that is the intersection, and that's the only elements that are in both sets. And here, this first set has 3 elements, but the second has only 1 element, the number 678. So these are disjoint sets. They have no intersection, non-empty intersection. Here we find the union of 2 sets, everything that's in one set, everything that's in the other set, and everything that's in both sets, and list them together. You want to notice that this can be finite or it can be infinite, and we don't have to list any element twice. So to close, remember, time is precious. Each day must count. Do the math. It will make you strong. See you in class.